The James Webb Space Telescope has been searching the obscurity for answers about the universe out there in the deep blackness of space. NASA's latest satellite in orbit has been taking amazing images of planets, stars, and cosmic systems. But now, something unexpected has been discovered. Something so massive that it threatens the foundations of all we know. It has scientists scratching their brains, wondering if this means the end of the world. Join us as we explore the possibility that the James Webb Space Telescope's most recent finding could wipe out the entire cosmos. By exploring the edge of the universe, we discover the point of observation. The observable cosmos serves as a kind of window that allows us to see the vastness that lies beyond. Everything that we can now detect, quantify, and investigate with the help of telescopes and spacecraft is included in the observable universe. It's an assemblage of planets, stars, and other celestial bodies visible to us. But the cosmos as a whole is much larger than the observable universe. Imagine it as a tiny portion of an immense, limitless pie that humans can examine and comprehend. While the overall dimensions and composition of the cosmos remain a mystery, our visible bubble is estimated by researchers to be 93 billion light-years wide. The distance that light, the fastest object in the universe, travels in a year is measured in light-years, which are approximately 588 trillion miles or 946 trillion kilometers. Thus, we are talking about a huge range when we say that the observable cosmos has a circumference of 93 billion light-years. The universe sprang into existence with an unimaginably massive explosion some 13.8 billion years ago, starting the process known as the cosmic expansion. The cosmos has not only been growing since its earth-shattering beginning, but it has been expanding swiftly as well. This acceleration appears to be driven by enigmatic factors, such as the puzzling dark energy, which appears to be pushing the boundaries of the cosmos further apart. Matter started to clump together as the universe grew because to gravity. Particles were brought together by this gravitational pull to create astonishing structures, including galaxies, planets like our own Earth, and stars. Imagine the cosmos whizzing by as these cosmic patterns took shape and transformed into the varied and breathtaking phenomena that the cosmos today. The universe is remarkably empty despite its immense vastness. The nearest star would still be roughly the distance of 2 soccer fields away, even if our solar system were reduced to the size of a quarter. This limitlessness gives us an idea of the vastness of cosmic space because it only exists within our own Milky Way galaxy, which is only one among billions in the observable universe. You might be wondering why it isn't possible for us to observe everything in the universe. This constraint arises for multiple reasons. First and foremost, even though light is the fastest substance in the universe, space travel still requires time. This implies that we are effectively peering into the past when we gaze upon far-off objects. An object's light has traveled more to reach us the farther it is from us. It's similar like exploring an endless time machine and unraveling the cosmos past. The universe is expanding as we see galaxies that are millions or even billions of light-years away. Imagine dots on the surface of a balloon that is about to burst. The dots will get farther apart as the balloon expands. The universe operates on the same principle. Galaxies, like those dots, are drifting apart as space expands. Redshift is the term used to describe the change in light emitted by far-off objects due to this expansion. In essence, when the objects move away, the light wavelengths stretch and shift toward longer frequencies, which are frequently seen as a reddish tinge. The cosmos is expanding, space is expanding, and light takes a certain amount of time to get through. So it's not strange that we haven't seen everything in the universe yet. These fundamental characteristics of the universe still restrict our vision, even with our extremely sophisticated telescopes and technologies. Many people from various fields have been fascinated by the pursuit of comprehending the universe's edge or limitations. Though conclusive answers are still difficult, 3 significant theories have surfaced, each providing intriguing insights into the infinite nature of cosmic space. According to the first theory, there is no limit to the universe and it expands infinitely. This theory is consistent with the cosmological principle and confirms the universe's isotropy, or uniformity of appearance from all angles. If this theory is correct, the cosmos appears to have no boundaries and appears to expand infinitely in all directions. The second hypothesis presents an alternative perspective, stating that although the cosmos might be limited, its edge is not clearly defined. Rather, it resembles a massive sphere or a curving area similar to Earth. This means that, similar to traveling around the Earth, if one were to travel in any direction indefinitely, they would eventually return to their beginning position. The intriguing idea that our world is only one among many others is presented by the third hypothesis, the multiverse theory. Imagine an infinite number of parallel universes, each with its own unique set of attributes, constants, and rules of physics. These universes may be completely separate from one another and run separately, or they could be linked together by complicated and sophisticated procedures to build a huge and complex multiverse. James Webb Space Telescope, JWST, reveals the mysteries surrounding the universe's huge beginnings, serving as a light of hope. This amazing device can see far beyond what was previously thought to be conceivable, providing us with an unmatched ability to piece together the unfathomable history of our universe. The JWST is a technical wonder created especially to make incredibly accurate observations of the universe. Our view is expanded to the earliest beginnings of the universe by its extraordinary powers. Recently, the JWST discovered 6 massive galaxies that date back between 500 million and 700 million years after the Big Bang. This information was reported in a revolutionary paper that was published in the esteemed journal Nature. These old galaxies are strikingly larger than one would anticipate for their early age, casting doubt on accepted theories of galaxy formation and evolution in the early universe. These findings are very astounding since they show how advanced these old galaxies were, notwithstanding presumptions. These massive stars exhibit a level of complexity similar to that of our Milky Way galaxy, which is 13 billion years old. These massive cosmic structures include an immense number of stars, each with a mass several billion times larger than that of our Sun. Surprisingly, one of these galaxies might possibly be up to 100 billion times more massive than the Sun, dwarfing the Milky Way's already enormous mass. The JWST uses infrared light, which is an invisible spectrum to the human sight, to provide its unparalleled ability to see the universe's hidden worlds. The telescope's remarkable power allows it to detect the feeble emissions from old stars and galaxies, exposing enormous relics that have persisted for billions of years. JWST functions as a kind of time machine, allowing us to travel across the ages and get a unique look at the universe as it was about 13.5 billion years ago. The continuing finding of enormous galaxies, which we lovingly refer to as universe breakers, has completely changed our perspective. It's a remarkable curve that contradicts most of the models we had developed for early galaxies, like rewriting history. At first, researchers believed that galaxies originated as tiny collections of stars and dust. It was thought that they grew gradually over time, becoming larger and more intricate. But when these massive systems were exposed by the JWST data and its high-resolution photos, the universe breakers destroyed these theories. These massive, unexpected objects from space seemed to have been there all along, defying our preconceived notions about how the universe had evolved. To go deeper, researchers examine light at different frequencies using spectroscopic techniques. The results of this inquiry will provide important information about these mysterious galaxies, including their size, composition, and distance from Earth. It's similar to a massive detective novel, solving the mysteries of these massive beings with the use of light. The astounding revelations made by the James Webb Space Telescope have advanced our knowledge of the cosmos to astounding heights. The identification of the oldest and most distant galaxies ever viewed has been made possible by this state-of-the-art telescope, which is run by an international team of space professionals. This discovery has been astonishing. These galaxies take us back to a time when the universe was only 400 million years old, following the Big Bang, and is far older than it is today. In the immense blackness of space, the James Webb Space Telescope has been looking for answers about the universe. This new technology from NASA allows it to take amazing pictures of planets, galaxies, and stars. It made a remarkable discovery recently that may alter our view of the universe's fundamental structure, leaving scientists perplexed and interested in its possible ramifications. The observable universe serves as a window into the vast area beyond when it comes to our exploration of the universe. Everything that we can now identify with our telescopes and space missions, including as stars, galaxies, and other celestial bodies, is part of the visible universe, but it's minuscule compared to the entire universe. It is estimated by researchers that the circumference of our observable universe is approximately 93 billion light-years. The distance that light travels in a year, or 588 trillion miles, is measured in light-years, which are almost unfathomable. The Big Bang, a massive explosion that started the cosmic expansion, occurred about 13.8 billion years ago. Since then, unexplained factors like dark energy have caused the cosmos to expand and accelerate. Under the influence of gravity, matter started to combine to form stars, galaxies, and eventually planets like Earth. The universe's enormous expanse is shaped by its continuous expansion, which limits our ability to witness some of its marvels. It is astonishing how empty the universe is given its enormous expanse. For example, the nearest star would still be roughly 2 soccer fields distant if our solar system were reduced to the size of a quarter. The only galaxy this grandeur exists in is our own Milky Way, one of billions in the observable cosmos. 2 main reasons why we are unable to see everything are the length of time it takes light to travel through space and the infinite extension of the universe. Some objects are too far away for us to observe because galaxies' light expands into longer frequencies as they migrate away from us. To measure these enormous distances, researchers employ units like light-years. The distance between the Sun and Proxima Centauri, the nearest star, is 4.24 light-years, whereas the Milky Way is roughly 100,000 light-years wide. We can look into the past and observe galaxies as they were billions of years ago by observing them billions of light-years away. Because of this cosmic expansion, our understanding is continually being shaped by the universe's accelerated expansion, pushing our observational boundaries in the process. The universe's size is explained by 3 primary theories. Either it is infinite and will continue to expand, or it is finite and lacks a distinct boundary, like a massive sphere or circle, or it is only one of many universes in a multiverse, each with its own set of physical laws. Even though these theories are theoretical, they challenge our perceptions of space, borders, and existence and pique scientific and philosophical interest. Important new information on the early universe's development has been made possible by the James Webb Space Telescope. It was created to view the universe with unmatched precision, and it has discovered 6 massive galaxies that date to a time between 500 and 700 million years after the Big Bang. The unexpected appearance of these huge galaxies' age challenges accepted notions of cosmic evolution. The JWST's infrared capabilities enable it to see ancient stars and galaxies that have lived for billions of years, which is essential to its ability to see the hidden realms of the universe. These universe breakers have been found, which implies that early galaxies were larger and more advanced than previously believed. This unexpected discovery suggests that the known mass of stars in the cosmos may be significantly larger than our estimates, along with the potential existence of massive black holes. Through its deep extragalactic research, JADES, which promises to disclose almost 100,000 distant galaxies, the JWST has also contributed to our understanding of the universe. Through the amalgamation of visuals from the Hubble Space Telescope and JWST, scientists have broadened their understanding of galaxies and the mechanisms that steer their evolution. Our knowledge of the cosmos has significantly expanded as a result of the JWST discoveries, covering everything from early galaxy formation to the enigmas surrounding black holes and exoplanets. These discoveries cast doubt on accepted theories and compel us to re-evaluate our conception of the universe, emphasizing the telescope's critical role in shedding light on the mysterious past and enormous potential of the cosmos.